It was a quiet morning on October 29th, 2025, when Harvard astrophysicist Avi Loeb shared something extraordinary. Fresh images of the mysterious interstellar object, Atlas. At exactly 7:47 a.m. Eastern Time, according to precise calculations from NASA's JPL Horizons, Atlas reached its perihelion, the closest point to our Sun in its cosmic journey. For astronomers, it was supposed to be a breathtaking moment, the kind that redefines our understanding of the universe. But as fate would have it, we couldn't see a thing. At that very instant, Atlas was completely hidden behind the Sun, lost in a blinding veil of light. Loeb revealed on his Medium blog that the object's most crucial moment, its encounter with the Sun, was happening right now, just out of reach of every telescope on Earth. The irony wasn't lost on anyone. The moment we most needed to watch, the universe kept secret. And that's where the tension begins. Astronomers knew that at this proximity, Atlas was enduring an intense solar bombardment, about 770 watts per square meter. If it were a typical comet, loosely bound by fragile ices and dust, that heat could be tearing it apart, right this second. But we don't know. We can't know. Somewhere behind the Sun's glare, a drama may be unfolding. A cosmic event hidden from our gaze, leaving scientists restless and deeply curious. Then there's the missed opportunity, the kind that makes researchers sigh in frustration. Loeb calculated that if Earth had been positioned just 6 months earlier or later in its orbit, we would have had a perfect vantage point. Atlas would have swung by only 54 million kilometers away, close enough for our radar systems to map it directly, capturing 3D images during its 16.2-hour rotation. It could have been our first clear glimpse of a true interstellar visitor in such detail. But instead, destiny placed us on the wrong side of the Sun. Even when it comes its closest on December 19th, 2025, it will still be 269 million kilometers away, too distant for radar, leaving us with nothing but unanswered questions. Still, the scientific world isn't sitting idle. Following a series of recent anomalies detected in Atlas's trajectory, radio observatories worldwide have gone on high alert. Teams are scanning the skies, listening for unusual signals, artificial transmissions, or sudden bursts of light. Anything that might hint at deliberate control or something non-natural. In the political sphere, Congresswoman Anna Paulina Luna has stepped in, pushing for the release of high-resolution images captured on October 2nd, 2025, hoping to shed more light on what's really out there. But before we get lost in the intrigue, it's worth asking, what exactly is Atlas? Officially named 3I/ATLAS, it's only the third interstellar object ever discovered, after Oumuamua and 2I/Borisov, but easily the most mysterious of them all. Measuring at least 5 kilometers across, it's 1,000 times larger than Borisov, and an astonishing 1 million times more massive than Oumuamua. To put that into perspective, SpaceX's Starship, the largest rocket ever built, is still 100 times smaller than this cosmic behemoth drifting through our solar system. And yet, size is only the beginning of its mystery. Astronomers studying Atlas have identified 8 baffling anomalies that simply shouldn't exist. Patterns and behaviors that challenge our understanding of both physics and nature itself. What exactly is Atlas? A comet? An ancient interstellar fragment? Or something else entirely? As 3I/ATLAS made its daring approach toward the Sun on October 29th, 2025, something remarkable happened. The interstellar traveler began to brighten dramatically, shining with a light that appeared bluer than the Sun itself. That unexpected hue immediately caught scientists' attention. It hinted that something unusual was happening on or near its surface, a mystery now unfolding right at the heart of our solar system. But here's the twist. Just as things were getting most exciting, 3I/ATLAS slipped behind the Sun, completely hidden from Earth's ground-based telescopes. On October 21st, it entered solar conjunction, the point where it's perfectly aligned with the Sun from our perspective, meaning we can't see it at all from here. Yet, almost poetically, this very alignment placed ATLAS within the view of several space-based solar observatories. It's as if the universe itself arranged for a few watchful eyes to keep following it when all others were blinded by sunlight. Those eyes belong to some of humanity's most advanced space instruments. First, there's Stereo-A, part of NASA's Solar Terrestrial Relations Observatory mission, launched back in 2006. Stereo-A orbits slightly faster than Earth, giving it a unique vantage point. Using its SECI HI-1 and COR-2 cameras, it captured ATLAS as it swept past the inner solar system. Its twin, Stereo-B, went silent in 2014. So for now, Stereo-A carries the torch alone. Then there's SOHO, the veteran Solar and Heliospheric Observatory, launched in 1995 and stationed at the Sun-Earth L1 point. With its powerful LASCO C3 coronagraph, SOHO has spent nearly 3 decades watching comets plunge toward the Sun. This time, it caught an interstellar one, something never before seen in its long career. Finally, the newcomer GOES-19, launched in 2024 as part of NOAA's next-generation weather satellites, joined the effort. It carries the CCOR-1 coronagraph, designed for space weather monitoring, but perfectly capable of spotting something like ATLAS streaking near the Sun's glare. Together, these instruments provided an unprecedented window into 3I/ATLAS's final approach toward perihelion, a moment we couldn't witness from Earth. The new paper, just released, compiles all this data from Stereo-A's HI-1 and COR-2, SOHO's LAS-COC3, and GOES-19's CCOR-1, covering September through October 2025. The result? A rare, almost cinematic glimpse of an interstellar visitor dancing in sunlight, growing brighter, bluer, and more mysterious with every passing hour. Harvard astrophysicist Avi Loeb recently made a bold move. He gave Atlas a score of 4 on the Loeb scale. On this scale, 0 means unquestionably natural, and 10 means definitively technological. A 4 might sound modest, but for an interstellar object, it's enough to raise every eyebrow in the astrophysics community. Loeb's reasoning isn't based on speculation. It's grounded in 8 anomalies so improbable that they defy everything we know about comets. Let's start with the first anomaly. Atlas's trajectory is almost perfectly aligned with the ecliptic plane, the flat disk in which all our planets orbit. The odds of such alignment? Just 0.2%. For something that came from deep interstellar space, where directions should be completely random, this level of precision is uncanny. Imagine tossing a dart across the galaxy and having it land precisely in Earth's orbital lane. That's what we're talking about here. Natural comets shouldn't know where our solar system's plane lies. Yet Atlas followed it as though it had studied the map beforehand. Then comes the second anomaly, and this one truly unsettled scientists. During July and August 2025, Atlas displayed a jet pointing directly toward the Sun, something that should be impossible. By the fundamental laws of physics, comet tails always point away from the Sun, pushed by solar radiation pressure. Atlas, however, defied that rule completely. Its anti-tail, a jet directed toward the Sun, hinted at something far stranger. Loeb described it as if the object had active propulsion, a mechanism fighting natural forces rather than following them. To call that unusual would be an understatement. The third anomaly only deepened the mystery. Atlas isn't just large, it's massive. And yet it's moving faster than any object of comparable size ever recorded. The probability of that combination? Less than 0.1%. Typically, heavier interstellar bodies move more slowly, shaped by the gravitational pull of their origin regions. Atlas, on the other hand, seems to have broken free of those rules entirely. A gigantic mass traveling too fast. It's as if something gave it an extra push. Then there's the fourth anomaly, which borders on eerie. Atlas's journey brought it close to Mars, Venus, and Jupiter, in a sequence so precise it feels choreographed, all while staying hidden from Earth during its closest approach to the Sun. Statistically, that alignment has a 0.005% chance of occurring naturally. Think about that. A perfectly timed planetary flyby, followed by a period of total invisibility from Earth, right when astronomers were most eager to observe it. It's almost as if Atlas had chosen its path to maximize planetary observation while minimizing human detection. A move that seems less like coincidence and more like intent. But the surprises didn't end there. The fifth anomaly struck at the heart of Atlas's composition. Spectral analysis revealed a plume rich in nickel, far more than in iron. A ratio typical of man-made alloys, not cosmic materials. In fact, the nickel cyanide content was thousands of times higher than that of any known comet, including 2I/Borisov. Such purity and proportion don't arise naturally. It's as though the object's materials had been processed or refined, not randomly formed in the chaos of space. The sixth anomaly was equally unsettling. Atlas is almost completely devoid of water, containing only 4% by mass. That's shocking, because comets are supposed to be 80 to 90% water ice, basically dirty snowballs from the edges of star systems. But Atlas? It's practically dry. Its composition is closer to that of a metallic asteroid or spacecraft than a comet. Whatever it is, it's not made like anything we've seen drifting through interstellar space before. And then came the seventh anomaly, one that made even veteran astronomers pause. Atlas exhibited extreme negative polarization, a light-scattering property never before observed in any known comet. Not even in 2I/Borisov, the interstellar visitor before it. The way it absorbed and reflected light simply doesn't fit with natural physics. It behaved, in optical terms, more like an engineered surface than a chunk of cosmic rock. One anomaly might raise curiosity. Two could be coincidence. But 7, soon to be 8, statistically impossible anomalies? That's something else entirely. Loeb's cautious score of 4 out of 10 might actually be the most conservative number in this entire story. The story of Atlas only grows stranger. When scientists analyzed the light polarization reflected from its surface, essentially how the object scatters sunlight, they were stunned. No natural comet has ever shown this kind of optical behavior. Light polarization is like a fingerprint of surface composition, revealing whether a surface is rough, metallic, icy, or dusty. But Atlas's signature? It was something entirely new. Whatever its surface is made of, it's unlike any material found on known comets. It doesn't just look different. It acts different, optically speaking. And then came the 8th anomaly, perhaps the most unsettling of them all. Atlas arrived from the same region of the sky as the legendary 1977 WOW signal, within just 9 degrees of precision. The odds of that happening by chance? Only 0.6%.